Hi, now we'll talk about kinetic energy and work energy theorem. After this section, we will see that work is energy. Work is shape of the energy, one of the energy shapes, and we will start know more about the quantity, the energy quantity. Okay. Now let us recall the equation of motion, which is v2 squared is equal to v1 squared plus 2ax. Divide over 2 just to move this 2 to be half of the squared velocities. It will be ax. Then multiply by m. Why we do these things? Because in physics we do these things always to move from quantity to another quantity in physics, to derive equations, to derive definitions of some quantities. If we multiply all by m, then we have m for an object. And if you remember from before, all of the equations of motions are without the existence of m. Now we need to put m with it and see what will happen. We have mv squared over 2 v2 minus half mv1 squared. It is the same, but final velocity and initial velocity, this will be equal to ax multiplied by m, max. But we know that ma from Newton's second law, it is a force, and x is a displacement, which is s. And from the previous section, we know that the force multiplied by a displacement is a work. Now we used the equation of motion, which is the second one of them, and we reach the work, the definition of work, which is Fs is equal to work. What we have on the left hand side, we have half mv2 squared minus half mv initial squared. This is a mass and this is a velocity squared. Okay, now what we can see that any moving mass with velocity v, we can put it in this equation, and this mass is carrying energy due to its motion. We know that if we have this is an object, and we have this is a moving mass. The pen is moving. Okay, it carry its energy, and this energy appeared when it is allowed to move this mass. So we have energy. The energy is called kinetic energy because it comes from its motion, because this mass has a mass and has a velocity. We need to square this velocity, multiply by the mass, and by half we will have a new form of energy, which is kinetic energy, and its name is K, and the unit of this energy is joule. Okay, so back to this equation, we have half mv squared final square minus half mv initial squared is equal to the work. The work is done to move objects. Okay, if the object is moving or change its velocity, then we have applied force. The applied force generate this work. The applied force make the object accelerate, then its velocity is changed from v initial to v final. So any work done by this force will change the velocity. The change in velocity will change the energy due the kinetic motion. So any work will change the kinetic energy. So if we give a moving body another work, it will change its velocity and it will change its kinetic energy. So this is the way the force give us acceleration, the acceleration give us change in velocity, the change in velocity give us change in kinetic energy, as we see from the initial relations. So the work will be converted to a change in kinetic energy for the object. Let us look at these examples to know what we are talking about. So the kinetic energy in general is equal to half mv squared. If we have a mass is equal to, we have three cases. For a small object and big objects, small velocity, high velocities. If we have electron with mass approximately is equal to 9.1 multiplied by 10 to minus 31 kilograms. And its velocity in the accelerators in the experiment is 2 multiplied by 10 to 7 meter per second. It is very high velocity. What about its kinetic energy? It is half m v square. M is this given and v is given. We need to square it. Then the kinetic energy is 18.2 multiplied by 10 to minus 17 joules. Okay? It is very, very low kinetic energy, but its velocity is high. Okay, what about a bullet? If the mass of the bullet is about 50 grams and its velocity is about 450 meter per second, then the kinetic energy is the mass multiplied by squared velocity. The mass in kilograms, we need to convert gram to kilogram. We need just to multiply by 10 to minus 3. And the velocity 450 squared. Then its kinetic energy is about 5,062 half joules. It is much bigger than this for the electron. We will discuss everything. What about the train? The mass of the train for the head of the train is about 600 tons, and its velocity not too much high. It is about 25 meter per second. Then if we need to calculate its kinetic energy, mass, tons need to compute to convert it to kilograms and square the velocity, it will be equal to 187,500,000 joules. It is huge compared to when we compare it to the kinetic energy of a bullet or the electron. Be careful. For electron we have very high speed, but the mass is very, very low. So the kinetic energy is very, very low. For the bullet, its speed is high, 450. It's too much higher than the train velocity. But the train kinetic energy is too much higher than the bullets because its mass is very high, larger than the bullet's mass. So we have kinetic energy, small and huge kinetic energies. And all of them are in joules using the same relation. Another example. If we have a mass, moving mass, its initial velocity is 10 meter per second, and its final velocity is 0 meter per second. So then its velocity, as we see, is decreased to reach the 0 velocity. We have the time during this motion is 5 seconds, and the mass is 2 kilograms. We need to find many things. We know many relations to use to find anything we need. We need to know, for example, the change in kinetic energy. We need to find the work done. What is the cause of that work? Look at this friction force. Why is the mass decreased its velocity? Because of the existence of this friction force. Compute the friction force. Compute the distance. If we look to this example as a problem in the test, it will be complicated. But if we divide it to its small pieces, it will be simple. The change in kinetic energy, it's simple. It is kinetic energy finally minus kinetic energy initial. Kinetic energy finally is half mv final square minus half mv initial square. The velocity finally is equal to 0. Then this term is equal to 0. The kinetic energy before m is known, v is known. Then the change. I'm talking about the change of the kinetic energy is negative 100 joules. The kinetic energy initially is 100. Finally is 0. 0 minus 100 is minus 100. What is the work? As we see from our relation here, the work is equal to the change of kinetic energy. Yes, here. So the work simply is equal to the change of kinetic energy, which is negative 100 joules. It is simple. What is the cause? We know that the cause is the friction force. We need to compute the friction force. The work relation is F multiplied by S, which is X in our case, and F is the friction force, and cosine phi. Phi, the motion is to the positive x-axis and the friction force to the negative x-axis. Then phi between them is 180. And that is why we have negative sign. Okay, the friction force is unknown. X is also unknown. We can't know X. We will, if we go to find the distance X from the fourth requirement, then we can find that third requirement. Go to the fourth requirement. X is equal to x naught plus v naught t plus half a t squared. The acceleration is unknown. The time is known. Time is 5 seconds. But the acceleration is unknown. The acceleration is simple to be computed, which is delta v over delta t. Delta v is negative 10. The time is 5, so the acceleration is negative 2 meters per square second. The v initially is 10. V finally is 0. 0 minus 10 is negative 10. Then we are able to compute the acceleration. Now, x is unknown. x0, we can assume our motion from 0, from the origin. Then x0 is 0. V naught is 10, as we know. The time is 5 seconds. Half is half. The acceleration is negative 10, as we computed here. The time is 5. We need to square it. Then x will be equal to 50 minus 25, which is 25 meters. So this is x is equal to 25 meters. We can use it in the previous equation. The work is negative 100. The friction force is unknown. X is known now. We compute it in the next requirement point, which is 25, and cosine 180 is negative 1. So we have negative, which will be positive. We have 25 multiplied by f is equal to 100. Then f is equal to 4. 4 multiplied by 25 is 100. Then the friction force is 4 newtons. So we can now use the work and the kinetic energy to find the properties of our system. Try to do these examples alone, and good luck.